Hello and welcome to step 12, which in this step we are going to keep with the theme of still working with right triangles. We're just going to look at a couple what we call special right triangles. So they're going to be right, but they're also going to have an extra quality to them. So this first one here is what we call our 45, 45, 90 degree triangle. So the reason we call it that, hopefully you can see, is that we have two 45-degree angles, same with here, right? Two 45s and then our 90. So with that, because two of the angles are the same size, the same measurement, we have two sides that are the same. So if we put these two together, it's as if we took a square and we sliced it down that diagonal. So we have these two sides that are the same. Notice they are opposite the 45-degree angles, right? They're congruent. And then we have this third side. Notice we see it as H. The reason it's called H is because that is our hypotenuse, right? If we have a right triangle, we always have a hypotenuse, always the longest side, always opposite that right angle. Okay, so to look a little more specifically, okay, those two sides, like I said, that were opposite the 45-degree angles, those are both just what we call legs. So if you want to say that L represents a leg. I brought this up in step 11. Any side of a triangle that's not the hypotenuse, we can just refer to as a leg. And then always that longest side is our hypotenuse. So those two sides will always be the same, no matter what. Whatever one is, the other one is. But our hypotenuse is actually longer, right? Because it's opposite the right angle. So the hypotenuse is whatever those shorter legs are times the square root of 2. Okay, so usually we would know one of them to find the other, but usually like we might know L is 5, and so then the hypotenuse would be, so like if these were both 5, then the hypotenuse would be 5 times the square root of 2. Okay, so if you want to make a little note for yourself, sometimes it's easier to just kind of have a cheat sheet. I like to say that if we're standing at a 45-degree angle and we go across from it, these are our L's. And if we're sitting at our 90, then we're looking for our L square root 2 across from that. Okay, so really the goal here is to know what L is, right? Is to find L if we can. Okay, so if we look at a couple examples, okay, so we know we have a 90-degree angle, we have a 45-degree angle. If you did not know, the three angles of any triangle will always add up to 180. So if we've already used up 90 and 45, then this must be a 45-degree angle there. Okay, so across from those 45s, these are the sides that are just our legs. Okay, so we can see that we already know what our L is, right? It's equal to 6. So the side across from our hypotenuse is our leg times the square root of 2. You can also think, if you want to think about it in a slightly different way, if you have the smaller side and you're trying to get to the bigger side, you want to multiply it by the square root of 2, right? Where we have a leg, we know the hypotenuse is going to get bigger, so we would multiply by the square root of 2. Okay, if you're more of an equation person, you can kind of write it out as an equation where the longer side is L, which is 6. Our x is L square root 2. So our x, whichever way you think about it, 6 times the square root of 2, which would just be 6 square root 2. No need to put that answer as a decimal or anything. You can kind of just leave it just like that. Okay, so let's look at one more. So we know these two sides, and we have to determine, are those the hypotenuse or are those the legs? Are they the smaller sides? And hopefully you're seeing, oh, well, our right angle is here, so these two must be our 45-degree angles. Across from the 45s will be the L's, or our legs, right? Okay, and if we're at the smaller side and we're trying to get to the bigger side, we want to get bigger, we want to multiply by the square root of 2. This one's a little trickier because it already has the square root of 2, so it's very tempting to kind of get rid of it. But we know that x is L times the square root of 2. So if L is 9 square root 2, we really have 2 square root 2's there that we have to multiply together. And before you grab your calculator, we can do this one in our head. So the square root of 2 times the square root of 2 is the square root of 4. Okay, the square root of 4, what number times itself gets us to 4? That would be a 2. So x would be 18. Again, if you just wanted to put this in your calculator, the 9 square root 2 times the square root of 2, you would still get 18. If you want to write it out because you're more of a procedural person, feel free to write out that equation as well. Just a couple different ways to think about it. All right, let's do one more. I think we'll be good here. Okay. So, we can see that we have this right angle. We can see that we have two sides are the same. I forgot to mention this earlier, but a triangle that has two sides that are the same is also called isosceles. So this is not only a right triangle, but it's also isosceles. So these two angles would be the same. Okay. And the one side that we know, this 12 here, actually ends up being our hypotenuse this time, right? It's opposite the right angle, right? Our hypotenuse. So we know that our hypotenuse is the big side, right? It's not the L, it's the L square root 2. So if you want to write an equation, you can say that L times the square root of 2 equals 12. Or if you'd rather, you can think, okay, if we're at 12 and we're trying to get to one of the smaller sides, instead of multiplying by the square root of 2, we're going to divide by the square root of 2 to get smaller. So we're either giving it the square root of 2 to get bigger, to find the hypotenuse. This time we're trying to get smaller, so we're going to divide it. We're going to take it away. Either way you want to think about it, we know that these x's are our l's, right? So we know that we're trying to get that by itself. So we got to divide by the square root of 2, divide by the square root of 2. And now we have this funny looking number, 12 divided by the square root of 2. You might not have worked with square roots or radicals yet, and that's okay. We're going to go over that right now. But we have to rationalize this, meaning we have to get that radical out of the denominator. We don't like that. We don't like it in geometry. We're not going to like it in algebra 2, and we're definitely not going to like it in pre-cal or calculus or anything else you take. So the way that you get rid of that is you multiply by that radical on the top and on the bottom of your fraction. So when that happens, 12 times the square root of 2 is 12 times the square root of 2, 12 square root of 2. And remember what we just did above. Square root of 2 times the square root of 2 is really the square root of 4. And the square root of 4 is just 2. So it's great. We have our radical out at the bottom, but we can actually simplify this a little bit more. This 2 on the bottom cannot change what's inside of the radical, okay, because the 2 is not in a radical. But the 2 can simplify the number outside of the radical. So 12 divided by 2, so our x is our L. 12 divided by 2 is 6, and then our square root of 2 there. Okay, so the big picture on these, if you're trying to get to our hypotenuse, we're going to multiply it by the square root of 2 to make it bigger. And if we're getting from the hypotenuse to the smaller side, the legs, we're going to divide it by the square root of 2. Either way you think about it, it's the same. All right, well, thank you for watching.